Yeah, welcome to my second talk today. I will talk about some nice aspects of a very typical use case of AD administration, which is joining. So making machines be part of a larger security entity called a domain controller. Nothing really new, but there have been really some very interesting developments recently, motivated by my work at Red Hat. So I want to present on that. First of all, I will present and explain a little bit about the history of domain joining in Windows, what it's basically really for, what really the core elements of joining are. I will then talk about this new mechanism called offline domain join in Windows and also in Samba, and then also elaborate a little bit on future tasks that we find necessary to investigate further on. So if you have any questions, you can at any time just speak up, or I might have a hard time following the chat, so maybe just unmute yourself and ask. Okay, first of all, what is really joining? So it's very simple. Joining means that you establish a trust relationship between a computer and a domain controller. That is done by typically creating a machine account in the domain controller database, which used to be the SAM database 94. Now, of course, in Active Directory, it's the LDAP tree. So store information in there, which consists of the properties defining a machine, like the machine account name, and most in particular also the machine account password, which is then really the shared secret between the computer and the domain controller, allowing you to establish all kind of security, secure operations between these two parties. So in this classic understanding of a domain join, you have two parties. You have a computer and you have the domain controller, and these two communicate with each other. So I try to visualize it a little bit. I'm very bad with these kind of graphics, so please don't expect too much. So on the left side, you have typically a computer, be it a whatever Windows 10 workstation or so. On the right side, you have a domain controller, typically AD, and you would call a process that really runs this domain join operation. It could be a library call, like in this case, it's the net join domain call, which is a very basic network operation library in Windows. You could also call any of the other tools that most likely also call this library call, or even more likely just use the Windows UI in order to join. So you would call, and by calling, you would establish a network connection between the computer and the domain controller. You would need, in order to successfully do that, use credentials so that you can properly authenticate. And what you end up with is then in the domain controller, you would establish this information defining yourself, like your host name and the password that has been generated for you. And this information will be equivalent on both sides, in both parties. So the client knows about the password and the domain controller knows about the exact same thing. So very fundamental, very basic, really nothing fancy. Now, if you look at this and try to adapt this scenario to more non-classic use cases, like whatever mass deployments of whatever virtual machines or things like that, you easily can identify a couple of restrictions. So first of all, only the computer can join itself. So it's not like a tool set available in the classic understanding, at least, that allows you to join other computers. So it also needs to have the operating system running. So it seems to be a trivial fact, but in order to store this information about the machine account password and so forth, it really needs to have access to the local file system and all these things. And secondly, there's also a network connectivity required to the DC. So you can't join without really having a good connection or whatever connection at all to the domain controller. And most often you also need to have strong credentials that allow you to join. So all these things really make it very plausible that there might be difficulties applying these mechanisms in kind of more modern data center centric setups, in particular when it comes to mass deploy large number of computers where you don't want to share delicate admin credentials and these sorts of things. Of course, there have been many things added to this classic understanding of domain joining later on. Like there are remote join APIs, which allow you to use DCRPC calls to join. That helps a little bit in automating. Then, of course, there's been added support for joining read-only domain controllers. So you might have whatever in your corporate network locations where you only have readable domain controllers. But even then, really making a successful join there requires many prerequisites. You need to set up replication policies and all these sorts of things. So it's a rather complex thing. In order to address all these concerns, in Windows, there has been a new mechanism established called offline domain join. That's available since already a long time, since Windows 7 and Windows 2008 R2. Most often there's a utility called djoin used for that. And this allows a couple of really new concepts. So first of all, the client and the joining computer can be completely separate. So it's no longer that you have the strict two parties, but you can even have a third party, someone taking care of joining a second party to a domain controller. I will visualize this in some of the next slides. So that's a very important differentiation. Then the provisioning step and the real joining are now completely separated steps. This hasn't been the case in the classic model of joining. It's also quite complex, but it will show up in the next slides when you see it in the graphics. Then by that, the domain controller connectivity is no longer really a strict requirement. So it's only necessary for creating the first step, which is the provisioning step, but not necessarily anymore for the joining step. So that's also something you'll see soon. And by all that, by providing these features, it now then really allows to join computers in locations which are completely detached from a corporate network, even in a very automation-friendly fashion. So in particular, when it comes to mass deployment of virtual machines, as I already mentioned. So again, some very bad graphics. On the left side, you see one client. On the right side, again, the domain controller. And you have a third party now, which is called samhost. So basically, you have two computers. And on the right side, you have one domain controller. Now, let's say that machine called anyhost decides it wants to create a machine account for samhost, the third party here down below. It would then call a new API call called net provision computer account. That's a Windows API call. Again, that would create the machine account, property, object, or whatever name it, in the domain controller, and it will be stored there. As the next step then, this API call returns all that information in some sort of defined structure. We'll go into the details later, and returns it to the caller. So the caller has now all the properties, like security properties, machine account, password, these sorts of things, not for himself, but for a third party, which is samhost down below. Now, okay, the graphics ate up something here. Normally there should be another image here. The next step is that somebody, like an admin or a person or whatever, transfers this box here. So unfortunately, it got lost in the next picture, but you have to just imagine it. Transfer it to samhost using a whatever, could be using a USB stick or something, or could even mail it, or by whatever means. Oh, that comes magically again. Okay, this is Google Docs. Now it is transferred to samhost, and the machine here can simply call now another API call called net request offline domain join, and that will basically establish the trust relationship between samhost and the domain controller by storing all that account information locally on this machine called samhost. So the steps are really completely separated. The account provisioning can be done by any third party. It could also, of course, be done by samhost. So that's really just in order to make this more visible. You can completely detach that. Provisioning step is one thing, and the request of the offline domain join, which is basically applying all that security content on the local operating system, is the second step. So when we looked in our team at this whole mechanism, it was really quite interesting. And we were wondering, okay, this exchange format, which is transported from the one machine to the other machine, how is it really structured? Is that some whatever very Windows specific thing that we might have a hard time understanding or debugging or researching or reading maybe even? And fortunately, it turned out to be quite good to understand and quite easy to read. Not easy to read, I wouldn't say that, but we'll see about some more details about that later. But at least it could make it possible to implement what we had in mind, which is to maybe we can also join this game of Windows offline domain join by fully understanding this exchange format and then really maybe writing our own tools or libraries or functions or whatnot, so that we can exchange that stuff and have whatever a Windows workstation let provision machine account information for us. We transfer that information to our host and we use it for our own purposes. So that was kind of the leading interest for that. But first of all, we needed to fully understand the data format which is used for these exchanges. And it turned out it is NDR formatted, and there's even an IDL for that. So IDL stands for Interface Definition Language, a very common property of all our DC RPC infrastructure. So we have IDL, we have an IDL compiler for many interfaces, of course, in Samba. This, though, is not really a network exposed IDL, but it's a part of the Win32 applications. So it's kind of living in a different area. And it makes use of some properties, in particular the MSRPC type serialization version 1. So it's using to a massive extent serialization stream pointers, which are a mechanism of the IDL compiler on Windows called middle to do hand marshalling of IDL-based structures and embedding them into larger structures. This is a property of NDR which isn't unknown to us, so we have support for that, in particular when we are dealing with the Kerberos pack and some very specific ways of encoding information in these Kerberos packs in Samba, so we are kind of familiar with that, but not to this extent when it comes to really nesting these pieces of information. So it took us really quite some time to convince PIDL that we can fully read and write these structures. And understanding, of course, that there is an IDL already available really helped a lot in fleshing out the last details. In the beginning, I myself wasn't aware that there is an IDL for that, so I basically started from scratch, trying to understand this structure. And you can see here an example of the most advanced networking research tools that we're using, basically the pen and paper, where I was just trying to understand whatever the serialization headers and offsets and the auto pointers and that stuff, with really some a lot of miracles that I had to solve. In particular, this last one, you see this yellow question mark here. That is still one of the last unknown things in that structure, which I believe is either a padding or a pointer artifact, something that we also have in the Kerberos pack IDL. So really a tedious task to get it all working, but in the end, we were able to really fully understand that structure. So on Windows, as I mentioned already in these other graphics, there are a couple of functions available to basically deal with that mechanism. Most prominently the first two ones, net provision computer account and net request offline domain join. The first one obviously creates the account. The second one then really adds the content to the local operating system. The later two versions, the later two calls, they have been added to extend that mechanism a bit more, in the sense of that you can also use these exchanged structures to pre-deploy certificates and group policies and many other things. The way these structures are defined really allows to easily add more in content there, even to add private mechanisms that could only be relevant for Samba or for some other vendor. So they're really basically just extending the initial model where you have this one block defining the machine account by just really establishing structures that allow you to store pretty much everything that you define based on your provided GUID. So I'm just a little bit here showing the header file definition of this first call, net provision computer account. You see it's really no big mystery what it takes. It's just the domain name, obviously, so the domain that you want to join to. The machine name, that's also a string that you need to define, that obviously defines the machine. You can, and these other things are all optional, like whatever join to a specific account organizational unit in AD. If you want to contact a specific domain controller, it can provide multiple options that have some fine-grained control about the provisioning process. And then importantly, the output of that function, you either get this provisioning information in a binary blob, or you want to retrieve it as a text string, which is then a little bit more handy in order to exchange it, for example, via files mostly. And yeah, so what the function does when you call it, as I mentioned, it connects to the domain controller using admin credentials. It will create the machine account for you and then return this encoded exchange data in either binary form or text form. This content you then just bring over to the other machine, and you call this other API call called net request offline domain join, and that will just really consume that blob basically, and you can give it some Windows specific path information if you want to join machines which are currently not even started. Like if you're dealing with the Windows VMs and the hypervisor, then you can also request that data to be applied on these non-started virtual machines, which is really quite cool. So it loads it, and for calling this function, there's no network required, there's no admin credentials required, whatnot. So it's of course very suitable for automation. The tool in the Windows space that implements or that consumes these API calls is called djoin, and yeah, it has basically two main functions. The first one is provisioning. The second one is called request ODG, so request offline domain join. And yeah, nothing fancy. The provisioning creates the AD object, returns the blob, and requires, of course, network and admin credentials. While the second subcommand takes the blob, applies it to the network, applies it to the operating system. No network required. The operating system does not even have to be started. So the output format of that text string is UCS2 or UTF-16, so Unicode encoded blob of a base64 encoded data of NDR formatted structures, and thus carrying heavily serialized data streams. So it's really, how many layers can you imagine? It's really nicely read, and it has to be really in this fashion. So I tried to also create these blobs, these structures, with just encoding them with a UTF-8 or something like this, and Windows will not accept them, so they will really need to be UTF-16, for example. So there's no way around this specific way of exchanging these informations if you want to use the djoin exit tool on Windows and the underlying library calls. This well-defined exchange format is then also suitable to be put into these Windows setup files. So there are XML files that you can use in order to automate joining. So there's some documentation available that I will show you later that explains exactly the XML files layout. And with all these things in mind, it's still, of course, quite important to know that you will, in what way you will ever exchange these blobs, you will carry over very sensitive cryptographic data around, because the machine account password, which is either a generated one or it could be even the well-known machine account password, which is the equivalent of the machine account name. So this is available in the API. You can still do that. This data is really very, very sensitive, and it will be in fact passed on in clear in these structures. So there's no way of encrypting it in that design. So if you look at the Microsoft specifications on the website, they have really this long note explaining the sensitive nature of that. Security note: the blob returned by the net provision computer account function contains very sensitive data. It should be treated just as securely as a plain text password. The blob contains the machine account password and other information about the domain, including the domain name, the name of the domain controller, blah, blah, blah. If the blob is being transported physically or over the network, care must be taken to transport it securely. The design makes no provisions for securing this data, and so forth and so forth. And then they explain that, yeah, the problem with exposing this kind of very sensitive information is already present if you're using these Windows answer setup files for unintended provisioning and so forth. So that kind of describes the sensitive nature of this whole thing. So probably not such a good idea to mail around these things, but to really choose some more secure mechanisms for transporting these offline domain join structures. So when we look at Samba, or when we looked at Samba, how we can implement such a similar mechanism here, of course, we have a very comprehensive infrastructure already available. First of all, we have this libnet join interface. This was in the very early years of my work in the Samba team, an effort to really bring all these various joining mechanisms into one central interface. So we had initially a net RPC join interface, which was only using RPC mechanisms for the join process. We had this net ADS join interface, which was using then LDAP and Kerberos mechanisms in order to deploy the machine account and these sort of things. So we had many different interfaces, and we just joined them all to this one central libnet join interface that is supposed to serve all the different use cases and scenarios. So we have this. We have a bunch of tools and libraries calling out to that, notably the net binary, but also the libnet API library. And we even have some DC-RPC workstation service that calls out to this interface. And we just added all the necessary hooks for offline domain join into this library, so that this one powerful central point of domain join capabilities could deal with these things as well. So with the work that we did, it's now able to consume and emit these ODG structures immediately suitable for further processing to this interface. The libnet join interface even got now some Python wrapper, which is really super nice, because then it can be called from the Samba tool, which is the core binary for administrating Samba 4 AD domain controller. Yeah, in order to kind of understand a little bit more the design and the mechanism itself, I also added these two API calls, which are existing on Windows, also to our equivalent libnet API interface library. So the net provision computer account and the net request offline domain join calls, not the other two. They just are stub implementations right now. So I kind of scratched that. I also created a tool which is the equivalent basically to the djoin utility on Windows, which really uses the same kind of commands and options. So make it a little bit more easy maybe for Windows admins to consume that. This is not yet pushed upstream or so. It's really just a proposed tool set and layout. But most people probably, when they are joining, they want to use the net binary, which is very common. And I just added a new command called net offline join, which basically calls into this libnet API library and then uses these two different API calls for provisioning and for requesting the offline domain join. That's of course all very abstract, so I would really like to show you some demo videos. Can you see the screen?
We can see a screen, but the one with the Google presentation currently.
Okay, I think I have to share something different. Let me quickly share again. I think I can just share my entire desktop.
Yeah, now we see a second window, terminal window.
Good. All right, so can you see this video starting?
No, not the window, just.
All right.
Singing the task.
We do see VLC.
Yes, here. No output.
Gunther, it's the same problem I had. You need to start VLC and then switch the screen sharing to the VLC window.
Okay, very clever.
It's weird since you have the whole screen shared.
Yeah. Okay.
If you have it on a different monitor, then
I have, yeah, for some reason.
Yeah.
Oh, we'll get there. So can you see this other black window now?
Yeah, now we see the video.
Okay, cool. Good. So let me start it. Yeah, it's starting. So this is just basically my development workstation. I just show you that I'm not joined currently to Active Directory. Winbind is not running, so there's no tricks involved here. So this is completely unjoined. I will now call the net offline join utility with basically the help command to show you the existing subcommands. The first one is provisioning in order to create the machine account NAD. The second one is the request ODG in order to request the offline domain join. So I will call the provisioning, obviously, first. Again, calling with help first so that you see the existing options. So you have domain name, which is, of course, a necessary option. This has to be defined. The machine account name. And then you either have to define that you want to save that returned ODG data in a file, or you want to print it out on standard out as a base64 encoded blob. So this again is really very close to what the djoin utility on Windows will do. So I give now the necessary input, my domain name, my machine account name, and I tell it to save it in the temp directory as net.txt. Yeah, okay, I forgot to define a user account that I really want to use when communicating with Active Directory. So I, just for the sake of making this fast, just use the administrator account. Okay, voila, that has succeeded. Now if we look at the returned data which got generated from this tool, we see this beauty of UTF-16, so the byte order element, and then UTF-16 encoded, base64 encoded NDR structure. And still, I am not joined because I just really used the provisioning step in order to lay out all this information to AD. So my local operating system, my machine is not modified in any sense. It now really requires to call the second step of this concept, which is the request ODG. And I will just feed it with the data that I have generated in the first argument and the first invocation of this binary. So I just give it the path to this created file. There's also this local OS option, which is kind of fake. It's just copied over from the Windows utility. You could really completely omit it because right now we don't have such a differentiation between local and non-local OS on Samba. I still have to give it, otherwise it will not complete. So command is completed. And if I now call netAD's test join, it will immediately show me, okay, my join is okay. I can start winbind and run some winbind specific commands in order to return some content from AD. So all this information really got completely absorbed into the Samba databases. If we look at the Varlib Samba private secrets CDB database, which is storing all this join information, including many other informational pieces like domain controller, DNS domain info stuff, and all these things. They are all, because it's all going through this libnet join interface, they're all filled up in exact the same fashion as if you would call netAD's join. So that's all there. Okay, so this is probably not so super exciting because it's basically just splitting the join process into two pieces. But if I show you the second video, we will now do something else. And that is, can you see the video?
Yes, we can see you.
Cool.
This works.
Cool. So now we are basically deploying this ODG information for a Windows workstation by just, again, defining the domain name. And here we give the machine account name of that Windows machine. Yeah, for some reason in the recording I made some other choices. So it's called win10 test. I saved the file, this time directly on a USB stick to really show you that I'm kind of also have the way of transporting this content over to the Windows operating system. Again, I give the ID credentials, of course. Now this information got created. Again, we can look at the beauty of this ODG structure with these various layers of encoding. So it will pretty much look the same like the first one. No big surprise. So now we unmount the USB stick so that I can mount it in my Windows machine. Ta-da, for Windows. Just to show you that this machine is not joined to anything, I just call this about your PC, which will display the machine name and the fact that it is not joined to anything. So it's really a standalone Windows 10 machine. And now I need to mount the USB stick. And I need to invoke the request ODG process by getting myself a PowerShell window. I need to run this as an administrator. So I'll just run it. And I call this djoin utility on Windows, which is really present in all the Windows versions on all domain controllers. So you'll find it everywhere. So you see it has the provisioning command set, just like the net binary, and also the request ODG set of commands. It has a bunch of more options here, which are currently not implemented in the Samba equivalent. So now I just call request ODG. I give the path to my USB stick with that Samba generated file. And I need to define the Windows path, I believe, as well. I always forget this. Because Windows really has this distinction between modifying the local operating system and maybe just a VM image. And in order to make it more obvious, you have to give these options. Okay, that has succeeded. So the provisioning information generated by Samba has been consumed by Windows. And we need to now reboot that machine to really make it fully operational. We could also have called this during the startup of this VM. So that's also a possible way so that you would not have the need for this additional reboot, but you would just join upon reboot. But these are just specifics of the Windows operating system. I'm going to speed this up a little bit because it takes quite a long time. For some reason I was doing something else during recording. So now I log on already with the an account from my Windows 2019 domain. Again, this here takes a long time. Speeding this up. Yeah, and now again I call this about your PC thing in order to show you that I now have joined Active Directory given that new name. So if you remember, it was a different name earlier, but now I renamed the workstation and joined it to Active Directory. Yeah, just join that this is really now an AD user. Okay. Now that's of course a cool thing that really shows the interoperability aspect of this structure, so that we can really do it in this direction. But it's even more interesting to show you the last video, which is then showing basically the generation of the structure using the Windows machinery, the djoin utility, and passing this information over to Samba. So just the other way around. Again, I need to call the PowerShell here. I call djoin again. This time I don't request ODG, but I do the provisioning because I want to provision my Samba machine. So djoin provision, again, I need to give the domain name because it could be a completely different domain that I want to create this information for, communicating with a completely different domain controller. I call my machine now sambaXP test. And I save the generated content again on my USB stick. So it's successfully provisioned. The machine is now created in AD, and all that information stored in that ODG text file. I need to unmount my USB stick. I need to mount it again on my Linux machine. So now you have this djoin txt, the newly generated one. Again, the beauty of base64 encoded files. And now I use again the net binary in order to apply this stuff on my local machine. At offline join, request ODG. I need to load the content from the file. Pretend that I want to modify the local OS. Yeah, now it's pointing out that I have an invalid configuration because I was not modifying my smb.conf in order to use that new the new NetBIOS name, the machine account name. So I manually need to adapt it. We also have mechanisms in order to automate these kind of modifications if we are using a registry-based smb.conf backend, but I wasn't. So I called it again after fixing it, so it was successful. I can now call again test join, and this information is immediately functional. I can call winbind, all these things again, will just work. Also, of course, that changed machine account name is now reflected in our own secrets CDB databases. So if you look for this new name, it's all there. So all that got updated. And I think in this video, I will also show you quickly how the structure itself really looks like when it is decoded. I just do this by calling it with debug level 10, and it's just printed out on the screen. I need to make the font a little smaller, otherwise it's due to this massive nesting, it's really very hard to display. So you see this is the ODG Win7 blob, which is basically carrying all this machine account information, including the password. The password itself is not printed with this debug level, so it's kind of protected from visual inspection. Then you have this DNS domain name info, which is part of that blob, including all the properties like domain GUID and SID of the domain, of course. Then you have the whole set of netlogon specific domain controller information, including IP addresses, all the properties, site name information, all that's encoded in there. Then there's always a second blob, a Windows 8 format encoded blob in there that carries a package part collection, which again, as the first element, has the same content like this ODG7 blob. But in this case, it has more other components like this package part join provisioning free, which is carrying the RID of the machine account and the generated SID and so forth. You see the other elements like encoded and non-encoded extension blobs, which are all empty. Now here you see the printout of the libnet join contents. So all that information from that blob has been fed to the libnet join interface. We see that we have an additional parameter for saying that we want to provision an account only. And here we pass down this entire structure again to the lower layers. And then here you see this generated secrets domain info, which is basically the content which we store in our secrets TDB, consisting of all that information about trust relationships and so forth, all that information which is now derived from that ODG content and updated from there. Yeah, so that's basically it. Then, yeah, you see that this has been successful so far for the demo. Let me quickly, I've already finished the time slot. Let me quickly show the last slides. Okay, you can see it?
No, we are currently not seeing any screen share from you.
Okay. Okay, I have to press share.
Now we see it, yes.
Okay, so we saw the demos. So what's next? Obviously, this concept and the implementation of that really opens up for many other interesting things. And particularly, we can you can consider use cases of this ODG mechanism for completely offloading the machine account creation in data centers to the AD admins. So they don't have to give you any specific AD credentials or so. They can just basically deliver you these ODG blobs, and Samba could just consume those in order to set itself up in data center environments, or in particular in those environments where you have more instantaneous setups and deployments, like containerized environments with Kubernetes, for example. For this purpose, I really suggest you to attend John Mulligan's and Michael Adams' talk tomorrow about the Samba operator, where this whole project, of course, was kind of also inspired or motivated. It will become very useful for these kind of things, because it gives us so much more flexibility and just provides a modern way for joining these data centers. There's some interesting noise, not for me.
I think it's from Chris.
Okay. Yeah, I'm almost finished. So there are a couple of next things, of course, to explore, like support for also deploying group policies, certificates, and so forth. That would be very interesting. Also, we could consider to embed our own data structures into this user structure, because it's really the way it's defined and structured allows for that. There's a lot of good documentation available for this, luckily. So I put them all into the slides here, a lot of stuff from Microsoft. And then finally, this morning, I even created a merge request for this. It's still a work in progress merge request, but still, you can look for this over there in our GitLab instance. And that's it.